solving systems of equations by graphing, why would we graph to solve a system? When I look at a system of equations graphed on a coordinate plane, what or where is the solution? So we're going to graph this system of equations. And why would we want to graph a system of equations? Well, if you're pretty good at graphing, it's real easy to get a quick visual, and especially if you just need an estimate. If you're trying to estimate whether an answer works or not, that's a really good way. But again, the better you are at graphing, the easier this way is. If you're not good at graphing, probably not your first choice. Still need to do it, and just consider it good practice at graphing. So I'm going to start by graphing the slope-intercept line. I'm going to graph the red line first. And I'm going to look at that and pull out the y-intercept. That's my y-intercept. And so we're going to graph the y-intercept first. That's a point. We can't start graphing a slope until we have a starting point. Then I'm going to pull out the slope. And my slope is 1. If I ask you to write the slope, you better give it to me simplified as a whole number or as a simplified fraction. But since I'm going to graph it, I'm going to use it as a fraction. I need to put its denominator there, or I need to use its denominator. But if I ask you the slope, don't tell me 1 over 1. That doesn't make sense. So I'm going to graph the red line first. And I'm doing it first because I want to remind you why it's beneficial to graph from slope-intercept form, especially if we're solving systems of equations. So I know, because my slope is 1, up 1 over 1, up 1 over 1, it's going to go through all these lines, all these intersections, all these points. And I know I'm a little wiggly here, but the benefit if we're trying to solve a system of equations is going to be, we're going to know exactly which points, which ordered pairs are solutions to this equation. And I'll contrast that. I will graph the other line from using the x and y intercepts. I was really surprised to find out that this particular year of Algebra 2, you guys really like using cover-up, and graphing from intercepts. And that's great. I'm glad you have something like you like, but you need to kind of know when to pick and choose. So if I'm going to graph my y-intercept, it's going to have 0 for x, so that's going to be -5. And if I'm going to graph my x-intercept, that's going to have 0 for y, and that's going to be +2. So I can use those two intercepts to graph. Y-intercept of -5, 1, 2, 3, 4, 5. And y-intercept, or x-intercept of 2. Now I can graph that, but because I don't know the slope of the line, I can't really tell where to go once I connect the dots. No, that's not very straight. I can't really tell where to go once I connect the dots. So notice, I'm going to be at the mercy of my straight edge to get me to the right place. So I'm going to recommend that instead of doing that, you get good at putting this in slope-intercept form. And some of you did that on the quiz where I asked you to graph from intercepts. You need to be able to do both and know which is the best course of action. So I got -2y equals -5x plus 10, divide both sides by -2. And now that I know my slope, I already knew my y-intercept was -5, but now that I know my slope is +5/2, negative divided by negative is positive. Now I can, say, oh, that makes sense. I was down at -5 on the y-axis, up 5 and over 2. Now I can go up 5 and over 2. 1, 2, 3, 4, 5 and over 2. And know that this is the next point on my line. And know that that's going to be where those lines intersect. So can you use the standard form to graph in order to graph systems and find their solution? You can, but I would recommend, it's going to be more often beneficial to put it in slope-intercept form so that you know how many to go up and over, so you know exactly where they intersect. If you can find it, if it's easy enough to tell without, and you like doing intercepts, awesome. But if you're unsure, again, always good to have two methods. So what is the solution to this? The solution is going to be an ordered pair, and it looks like it's 4, 5. 4, 5 looks like it's the solution to that. And I could do some quick math. I'm quickly and mentally plugging it into the red equation. 5 equals 4 plus 1, yep. Quickly plug it in mentally to the blue equation. 20 minus 10 equals 10, yep. So that worked. So this was my equations, and there's my ordered pair. Just like when we've done other methods, we have a system of equations and ordered pair. We could double check it also by solving by one of the other methods, but looks like we're good there. This time, we've got a special line. One of our lines is going to be y equals x. And you should be really happy whenever you get this as one of your equations, because you know something very special about all the points on this line. Also, some of you freak out when you see a fraction, but remember, we like fraction slopes when we're in slope-intercept form. So what do I know about all the points on the line y equals x? Well, we know that the x and y values are equal. Yes, I can graph this thinking about its y-intercept is 0 and its slope is 1 or 1 over 1, but I really want you to get comfortable knowing just that y equals x is this line directly in the middle, 1, 1, 2, 2, 3, 3. So the reason I say this is a nice one to get when you're solving a system, if you get an answer like 2, 7 or 4, 5, you know it's not right, because every x value is the same as every y value. So you better get an answer like 1, 1 or 2, 2 or 0, 0 or negative 5, negative 5. Okay, now the other equations in slope-intercept form. So my y-intercept is 7 and my slope is negative 3/4, so it's either negative 3 over 4 or 3 over negative 4. Make sure that you get your mental picture of what a negative slope line is. 1, 2, 3, 4, 5, 6, 7. Okay, can't really go up 3 and left 4. Can only go down 3 and right 4. And there's my solution. Down 3, just to get another point, right another 4. I think I went down 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So we know that that point on that red line is going to be the same number, same number. So then it's a question of what is it? Well, let's see. 1, 1, 2, 2, 3, 3, 4, 4. Looks like it's 4, 4. So it looks like our solution is 4, 4. The simplest of all examples that will absolutely throw some people. What if I have a line that's a y line without an x? Well, that one's pretty simple. What if I have an x line without a y? That one's should be just as simple, but you can't really reason your way through it. You just have to know what to do. So if those are my two equations, what's my answer going to be? Well, I'm going to tell you right now, it's going to be 3, negative 2. How did I do that without even graphing? Well, let's graph it and find out. What does a y line of negative 2 look like? Well, you can go ahead and think of it, and I was going to do it next to it or below it, and I realized that was not a good idea. You can say, well, my y-intercept is negative 2, and my slope is 0. Well, the slope is 0 just means it's a horizontal line. It's a horizontal line at negative 2. So there's my y line. And then x is 3. You just have to know that your x lines are vertical. Think about the fact that we know that it doesn't have a y-intercept, it has an x-intercept. We know that x equals 3 is all along this line. We have x equals 3 when y equals 1, x equals 3 when y equals 0, x equals 3 when y equals negative 1, x equals 3 when y equals negative 2, and that's the solution right there. So if we know we have a vertical and a horizontal line, every line on the vertical line has a 3 for the x, every point on the horizontal line has a -2 as a y, so it's the only place they intersect. Y graph to solve a system can be a really quick check, especially look at that vertical and horizontal one, or if you have a y equals x one. There's shortcuts. I wouldn't do it for every system, but some systems just call out for it. And when I look, what's the solution? It's where the lines intersect.